Hello everyone. In this video we are going to discuss about integrity constraints in DBMS. So what is a constraint? Constraint is a set of rules or restrictions which are needed to be followed while inserting values into the database. So there are total 4 types of integrity constraints. First one is domain integrity constraint. Second one is entity IC. Third one is key IC. Fourth one is referential IC. Now let us look into the first one, which is domain integrity constraint. Domain constraints are the type of integrity constraints that ensures the values stored in a column or a attribute of a database are valid and within a specific range or domain. Suppose let us consider a relation or a table called student. The student has different fields like student ID, student name, age. Let us consider these three. So while inserting a values into the student ID, it should have either a number or a variable character. While inserting a value into the student name, it should follow only string. It should not accept other formats like an integer. And similarly with age, it should accept only an integer value. It should not accept a string or a negative number. So these are called the data types. There are different data types in domain integrity constraints like a string, char, time, integer, date, currency. Now let us understand clearly with help of an example. So this is the relation student or a table student, and it consists of 4 different types of fields or columns. First one is student ID, second one is name, third one is semester, and the fourth one is age. So in this, the first 3 fields, which is student ID, name and semester, should accept only variable character. Suppose if we are trying to insert a name called 123 hashtag in place of Ankit Kumar, it should not accept. Similarly, the fourth field is age. It should accept only integer values rather than accepting a string values or a negative number, because an age cannot be a negative number or a string or in string format. So this is about domain integrity constraint. Now let us look into the second type, which is entity integrity constraint. Entity integrity constraint state that primary key can never contain null values, because primary key is used to determine individual rows in a relation uniquely. If primary key contain null values, then we cannot identify those rows. So here, what is primary key? Primary key is used to represent the entire row or a record. Let us understand clearly with an example. But before, let us see what are the characteristics of a primary key. The primary key must be unique and it should not be null. Now let us understand with help of an example. Consider the table or a relation called student. It consists of 4 different fields or columns. First one is student ID, name, semester, and the final one is age. So in this, let us consider student ID as a primary key, because the student ID represents the entire values of Ramesh of 5th semester and his age. Similarly, the entire student ID of 102 represents name, semester and age. And similarly, the third and fourth records also. And similarly, we discussed 2 different characteristics of primary key, which are it should be unique and it should not be null. So observe the 4th record of this table. It consists of null values. So this should not be accepted, because the null values cannot represent the entire row or a record. So this is about entity integrity constraints. Means simply it is a primary key, it should be unique and it should not be null. Now let us discuss about the third type, which is key integrity constraint. Key constraints ensure that certain columns or combinations of columns in a table uniquely identify each row. There are total three characteristics which are prevent duplicates. Second one is maintain relationship between tables, which is via foreign keys. And the third one is enforce data integrity. So let us understand about key integrity constraints with the help of an example. So in this, consider the relationship or a relation or a table called student. It has four different fields, which is student ID, name, semester and age. And here student ID is a primary key. This represents the entire row or a record. Now observe the fourth field of the student ID. It is as same as the second row or a record of student ID. So as we discussed earlier, the primary key should prevent duplicates. Means it should be unique. So this should not be accepted. Either the second row or the fourth row must be deleted from this relationship table. So after removing the fourth row, the final table is as follows. Here is the below example of student ID is the primary key attribute. The data entry of the fourth tuple violates the primary key constraint that it specifies on the database schema, and therefore this instance of database is not a legal instance. So this is about key integrity constraints. It is a primary key where it should prevent duplicates. Now let us observe the fourth one, which is referential integrity constraints. RIC are rules that ensure relationship between tables remain consistent. They enforce that a foreign key in one table must either match a value in the referential primary key of another table or be a null. So in this referential integrity constraints, we are going to discuss about two key concepts, which is primary key and foreign key. Let us understand clearly with the help of an example. So consider two relations or a tables. First one is student. This student table has four different fields, which is student ID, name, semester and block number. In this table, student ID is a primary key and block number is a primary key. Similarly, consider the second table, which is it has two different fields or columns, which is block number as well as block location. Here block number is a primary key because the block number represents about the block location. If 20 is a block number, then the location is Chandigarh. Similarly, 21 is the block number, then the location is Punjab. In the same way, 25 is the block number, then Delhi is the block location. So in referential integrity constraints, the foreign key in one table must be a primary key in the another table. So by seeing this example, by considering this example, the block number is the foreign key in student table. It should be a primary key in the second table. The first condition satisfied. Now observe the second condition. The foreign key in one table must either match a value in the reference primary key. The foreign key in one table, which is 20, must match its primary key in another table, which is 20 in the second table. Similarly, the foreign key of 21 in student table must match the primary key in the second table, which is 21 in the second table. Similarly 20, but observe the final one, 22 foreign key in one table doesn't match the primary key in the second table because 22 is not present in the second table. The fourth record must is invalid and it should not be accepted. So this is about a foreign key and a primary key concepts. So this is about a referential integrity constraints. Thank you for watching. Please like, share and subscribe. If you have any doubts or any suggestions to improve this video, please comment.